Hello, everyone. I think people don't know me. I'm Robert McDermott. So the principal architect of our IT department. So, first of all, I'm not a scientific researcher here. I'm just a nerd. Um, I've been here for
We all are nerds.
what's that?
We all are nerds.
Here, no, so yeah, I've been at the center for almost 26 years now. So, I'm not a researcher, but I, help with a lot of things enough to understand, the basics. But I gave this talk a couple weeks ago to the IT department. They was focused more on like getting them up to speed with engineering, so they understand how, talk to customers, because people are kind of more fluent in these things. So I took that and I adapted it for each. So some of the stuff might be remedial to a lot of you, but I mean, it's just the whole purpose. This is the crash course, like, broad, like all the things you need to know, like, you know, you know, we're not going to go too deep, but it should give you a good idea of like all the working pieces. I should mention, yeah, I'm in IT, but I'm in a department called research. Our job is to kind of like internal consultants, you meet with customers and real, researchers and people at the clinic and try to help them solve problems.
So one thing about that first, Robert, so how do you work with the high data as for FRH?
No, we're not involved in one. So that's yeah, there's an outside group, and that's Jeff Lee, and with Brian Boss, but we're not really involved with all because none of the infrastructure is here at the center until external.
So your infrastructure is external or their infrastructure is
There is an external. Our, we have we're the like the global infrastructure here. We only have some cloud infrastructure here, but we don't manage any infrastructure for Kai.
which building are they located? And
Right now IT is in 501 East Lake, so it's like a half a mile from here to walk. But
so, Robert, when should we contact you versus IT services?
that's a good question. I'm not here, but you can send us an email on like we'll try to triage things, like do an initial consultancy, like what you're trying to do, and then determine what to do next. That usually rather than I think that if you can send it to the service desk, they might not know what to do with it. If it goes to PMO, then that's a project. It might get lost there too. So it's probably if you're trying to do something novel, like reach out to my team, to me or Bridgeworks. It's just Bridgeworks at Fred.org. And like we'll meet with you to like discuss what what you have in mind and try to direct you to be the right place, or maybe we'll be able to help you directly.
Yeah, so it will be good for us to know what kind of questions should we ask you or after.
Oh, okay.
Yeah, thank you.
All right. So again, it's kind of like I said, it's remedial. It's like high level landscape. AI is a very loaded term. You do a lot of things, and what we're going to focus on, today, the generative AI, or the part that got exciting like 3 4 years ago. And basically, we're very high level how LLMs work. The most rudimentary of those, is tokenization. So LLMs don't understand text and sentences and language per se. They work on numbers. So the first thing is they have to be embedded, the words. So what an embedding is we take all the words that are in a language and you can break them up and assign identifiers to them. That's called tokenization. As you can see, a whole word does not equal, they're not tokenized equal. Some words are broken up. The rule of thumb is like, 4 words in English per token. And then you can see the example there, there's like a set in a paragraph and you see it, it's, calculated to an array of embedding IDs. I think what they help with that is the next part is now you have the tokens. So now I can use embeddings. And what embeddings are is you basically capture the semantic meaning of words and sentences in an array, like in a vector. You can see like Bravo 1 and CP53, they're pretty related. Like those are very dimensional. So like 768 dimensions or something. So the small. So you see, yeah, there's some what you can see they're kind of related, aspirin, not at all. So, and the way they determine closeness, you'll see later in the model, it's like there's a couple methods, but cosine similarity of the vectors as the most common method, and you use them for like semantic search, drag, which we'll talk about a little later, classifying things, making recommendations, and then just like 4-line Python, you can turn a sentence into an array of embedding. That's something to do. And again, there's a lot of different models, embedding models, and a lot of different models use they have their own special, and there's even a leaderboard which embeddings capture the most, semantic information.
So where's the leaderboard? Where do we find it?
It's on Hugging Face. I have a slide about Hugging Face as well on there. But yeah, the Hugging Face has a leaderboard, so like open models and the embedding models, stuff like that, where it's updated every day, like kind of like a rank system. But some don't perform better than others. Performance wise, some capture semantics better, but you kind of And I was like, so really, I was really fascinated by embeddings and what they were. Like when I started learning about them, several years ago. So I created this. It looks kind of lame, but this is like some Python and Plotly. I use word to vec, and I created a little thing where I can train my own little model using the word to vec thing and reject the cloud words to capture clustering the semantic needs, different words and stuff. And it's kind of cool. It's interactive, and there's a 3D version of that too. But that was 3 years ago, or almost 4 now. And then this is the same thing, but out at the sentence level. And you notice this one is like GPU accelerated. It flies through. It's like it's beautiful actually. But that one's like, that's an envision of the and more self-produced, like it's such a lost time. And the difference between the quality of those two is this is me by hand doing it by hand. That's me, Robert with the help of AI to come here code. You can tell the difference in quality. Next thing there's parameters. All models have parameters. You hear them people talk about a lot. Just basically the number of tunable weights in the model have, and the more weights there are, the more complexity and the more information it can handle on the margin reason. And you see some of the commercial models like the GPT line, as I started out, 2019 was the 1.5 zillion parameters, all the way to now it's estimated, we don't really know for sure, but it's estimated around 10 trillion parameter model. And then just in comparison to some of the open weight models. So Llama 2 was 70 Ps, and now currently GPT-4 Pro, which came out like a couple months ago, that's like 1.6 trillion parameters. So they're getting bigger, a lot bigger. And I meant those to occur that too. That all the estimation of around 10 to trillion tokens score. And basically putting those all together, how it works is when you give it a prompt, it tokenizes the words, the sentences to generate the vector to understand what the prompt is. And then look at transformer, which there's been talks that you learn something about that. I'm not going to do how transformer works, but it's going to transformer. I'm going to score. It's going to score them and show the next possible probabilities of the next token based on what you're giving it, and then it'll score them, and then it'll sample and pick one based on the temperature settings, tau p, tau k. There's a bunch of different settings, and you can see here it's like tumor suppressor gene TP53 is the most possible. The top 5 is mutated, so you choose as the next word, append it to the front, and then add it to the front again, and go back in the loop until it's like once until it finishes the whole. There's different types of models. There's dense models and mixture of experts. And a dense model, every parameter is activated for each token that's generated. So the entire, every weight parameter is being used. A mixture of experts, it basically only has a router that based on the token, it predicts which experts would be the best actually to touch it. And what an expert is a collection of these parameters that are tuned for specific tasks. So when if you're deploying these locally, one good thing to note is that it's the same precision, the same quantization, the same number of parameters. They both require the same number of amount of VRAM for running your GPU. But the mixture of experts will run much faster token generation because it has much less compute overhead. It's only activating a subset of tokens. Parameters. So, for instance, like a 32 billion parameter model might only have 3 or 4 billion parameters that are activated at any given time. So it's a lot more. It's faster. But it has the same memory requirements. But then the dense models are often smart. But so there's a trade-off with all this stuff. Configuring and running on the context window, and it's super important thing to understand, is that's how much, the scratch pad, of how much it can hold in its, and, in its mind at a time when it's thinking about something. They've grown dramatically. So, 2 is only 4K. And like the latest models now, we have like, so, Opus 4.6 and GPT 5.5 and Gemini 3 Pro, they're all at 1 million context token links now. So they can have dozens of papers, several books, all at once. In their short-term memory all at once, while they're reasoning about things. But there's a cost to that as well. So if you're paying a commercial model, you're paying by the token. So input tokens and output tokens you pay for, so it costs more context you use. On local models, you increase the VRAM overhead, so you might run on the RAM on your local GPU. Then there's also, this is kind of been addressed with most commercial models now, but there's a lock in the middle effect where if you give it a lot of information, it'll remember everything at the beginning, and at the end it kind of forgets stuff in the middle. So that's kind of diminished now with a lot of the commercial models. They've addressed that, but open source models, it still exists. The parameters, we're not going to cover all of these, but these are like tunables on the model when you're run inference. So the most common is temperature. Basically, that's like the creativity dial, and the temperature of 0 is just like whatever the next, probable token is, just you just go with that every time. You turn up the temperature, it can add a little bit of more randomization to that. So if you want concrete facts and, software development or something, you probably want the temperature very low. If you're doing creative writing or fictional story, then you create, or you're doing brainstorming of new ideas, then you might want to try to creativity. And the other one to remember is like the max tokens. So that's not, hey, give me this many tokens in response. It's like, it's basically putting a cap on it. Like your response can't be bigger than X. And you want to do that to, to constrain it so you don't burn up too many, you just cost money, you're costing money a token and then. So those are the other ones are, I don't know how to use the other ones too much. Sometimes if you're doing an open source model and it's responding, all of a sudden it goes, it just says the same word over and over again. You can increase the frequency penalty to stop from doing that. But other than that, the temperature and max tokens are the ones that you normally have to tweak.
So you mentioned sort of how much creativity comes into play. What about sort of hallucinations? Is that sort of correlated with people?
Yeah, probably. I would assume so. It's better at making stuff up more. But at quantization, this is just really, if you're using a vendor, you don't really need to know about this. But if you're running it like on our systems here, you're on your laptop, quantization is really important. Like a full model, like when they do the full training of it, it's 32-bit precision. What that means is the weights are 32-bit floating points, so it's full size. But then normally the models, when you're doing inference, they're 16-bit, so it's like half the size. But it takes a lot of memory. So with quantization, you can like reduce the precision of the weight, the bits of the weight, all the way down to like integer, 4-bit integer, to make it dramatically smaller. So like if you're running on your like laptop or computers we have here, you probably want to run quantized 4-bit quantized model. And like for instance, you can run a 32-bit. I run a 32-bit billion parameter model on this MacBook Air with 32 gigs all the time, about 4-bit. And there's other things probably need to know about K quants. They see the K_M. That's usually the one you want the median the most. They come in different sizes and the different file formats. We'll talk about that. So these are normally the 16-bit, X16, the higher ones are they're safe tensor format, and then the quantized ones are GGUFs. So we'll talk about that in a little more detail. Yeah, here we go. Platform. The old model is a pickle, which is basically just a serialized, Python object, which can be dangerous because when you read it deserialized, it can execute commands and things. So those are tend to be avoided now, but now they have a new format called safe tensors. That's literally the example. So name of the model dot safe tensors, and those are safe. They won't, when you're deserializing it, they don't execute any code or anything. The GGUF, which we just talked about, those are also safe, and those are the quantized versions that you can download on model download locally. And then there's this vendor neutral one, which I run one time, a little tiny one on a voice chat app that I did to make it so I can run it on different hardware platforms. It's like a vendor neutral.
On your last slide, you have a quantization. You have the symbols that reduce the precision of model weights to shrink size and speed up inference. I just want to clarify this. What do you mean by speed up inference? Do you mean by speeding up the model prediction?
Yeah, the tokens per second. Yeah, so it's like the malware is much smaller. So like 32-bit floating point integers, like billions of them. It's a lot more computation intense than 4-bit integers. So
I see. Yes, the reason is that here our audience, many of us are file statistician. We use inference to mean a totally different base. Yeah, it's a jargon confusion. Yeah. Thank you. Yeah.
Yeah, inference just like how to generate tokens. Yeah.
Okay. Yeah.
It's like
Question. What is the payback for reducing the size of knobs?
way less overhead in memory. So the file size,
But does the quality of the
yes, it reduces the quality, but not dramatically. So the size will reduce dramatically, but then the quality might only be down 10% lower or whatever like that. It depends on the quantizations because there's a lot of parameters and stuff, but it makes it run on smaller hardware, way less overhead, file size, memory size, but there is a penalty to quality. But not as much as you would think. It pays off on the size. It depends on the application. If you run on your laptop for a little, thing like that, then yeah. But if you're running a big scientific pipeline, then you might want higher accuracy, like on big iron GPUs. And then this is like kind of what we're talking about, the requirements, memory, the thing, or just kind of a rule of thumb, or how much DRAM, it's the memory that the GPU has on its card. You have to load everything in the GPU memory. Some systems can share between system and GPU, but then the bus becomes a bottleneck and gets really slow. So you want to load everything in your the GPU's VRAM. If you're running into like a Mac, it has unified memory, so it doesn't matter as much. But these calculations still matter if it fits. But the rule of thumb is like how much VRAM you need is the bytes per parameter plus 20% overhead for the the key and value cache and the context and stuff. So as you can see, like 13, 14 billion parameter model at F16 precision, you need 31 gigs of RAM. But at 8 it only needs 16, and at 4 it only needs 8 gigs of RAM. So half a byte per parameter for 4 whole bytes, and then 2 bytes parameter for F16s. And nobody really does that, floating point 32 for running inference. That's just for training. But you can kind of see how you fit using the integer models on whole level GPUs we have here, or even your laptops.
Do people ever benchmark these different trade-offs, like number of parameters versus the resolution, the bytes, right? Because you can have a bigger model with the lower resolution. Like
Yeah, of course. Yeah, I mean, it's because I'm sure someone's done it up there, but I mean, personally didn't. But yeah, I'm sure there's papers. I mean, it's papers on everything. I'm sure that somebody's done those benchmarks. And then these are just some of the common GPU size. It's like 5090, fast game. What you get, it's like 32 gigs of RAM. L40 we have those in our Gizmo cluster. It's 48 gigs per card, and we have multiple cards per box. We don't have any of the bigger ones yet, but we have they're on the word now. We got to invest 10 grand, so we have a lot more L40Ss, and then we have some of the H200s. Some of the big GPUs are coming soon. They're shipping out site by I think July 1st, but then they probably won't be ready for use until the end of the year. But then we're gonna have a lot more GPU power here on-prem soon.
And they are all available to all the researchers here.
Yeah, it's a research staff. Yeah, for as long as you're for grant-funded research. So as long as you're doing grant-funded research, the cluster is available for use, or it's a shared resource basically for around the center.
And then paid from the S10 one?
Yeah, S10 can work. And the different types of architecture for the GPUs, more common are NVIDIA, so it's CUDA, and then Atlas Silicon. So I pretty run on a Mac and one of there. The other ones are kind of like emerging and growing, but in general, CUDA is the industry standard. That's where like NVIDIA and all OpenAI, they're all running on CUDA. It's where you got to train. You have some special like Cerebrus and some different architectures now that are just like for inference only, not training. But CUDA and NVIDIA is still the king. But those are again. So if you have an Atlas Silicon Mac, any of them, the 16 gigs of RAM, around those kind of model. And then this is like versus cloud. So there's pros and cons of each. So if you're gonna self-host it or run locally, number one thing for me is like I don't have to worry about my data accidentally leaking or doing something with sensitive data because I'm already allowed to have access to the data, stays on my computer. So if it's self-hosted, the data doesn't go anywhere. The data stays safe. You don't pay per token. You have full control over everything, all the parameters, the model you're using. You don't even need the internet connection if you want. You air gap. The downside are you have to buy a GPU. You have to manage and scale everything, and you're limited to the open source models, which they're really good now. So it's not too much of a limit. You're still not as good as commercial models. The cloud, if you're going to go the vendor model, they just simply have the best model, like the GPT 5.5 and Opus and Gemini. They're not going to be able to run anything local that well yet. Some are getting close, like PK2 and some of the other ones that are they're in a trillion parameter size that are getting close, but the commercial ones are still beating. There's no hardware to manage, instant scaling. You always have the latest model. But then the dangerous part is data deep in your network. So if you don't have an enterprise agreement or a BAA with them, and especially you wouldn't want to do it with like a consumer grade ChatGPT or anything that's where the data might be actually trained on. That's kind of a risk there. And then you're paying per token. You pay for input token and output token. You have different costs for each. And then you're dependent on the vendor. If they have outages or rate limits or whatever. So there's the pros and cons of both. And then I'll talk about briefly, I think it's in the next slide about how you can run locally.
Can I ask you a quick question?
Yeah.
Where does accessing the resources via the cluster fit into the slide that you just showed? Because you're going to be kind of somewhere in the middle and
it's over here. Yeah, it's on that self-hosted side. The only thing about it is it's not your own hardware, so it's a shared resource. So you'd have to each lab is allocated a number of like cores and time on the cluster. But yeah, you fit over there. The data stays here on-prem and never goes anywhere. So basically all the same benefits apply here. So you guys don't have to mention like IT does. But it doesn't cost anything. We don't charge for GPU usage at all. So yeah, the local cluster is it has all the same benefits as the local. And again, right now, the largest GPU cards, I think there's like 4 or more cards. Yeah, 4 cards, L46s in one box per box. But they're only 48 gigs each. So you can't run huge models because those ones, they don't have, they're not networked together, so they're all independent. Some of the new cluster nodes you're getting have H200s that are networked. So you can have 8 H200s in one box that are all networked together. So it appears as one gigantic GPU. So that's going to be, then we're going to be able to run large models. So that'll get pretty exciting. So you guys should start working on use cases too. You didn't mention those. Now, ways to run it locally, if you want to run it right now, it's like, Ollama is like the most popular way. That's like really simple. You just install it on your laptop. LM Studios, I'd probably recommend that for an absolute beginner because that one comes with a nice chat UI, and it does expose some of the tunable parameters more than Ollama does. It can run MCP. You can connect MCP servers, this other stuff. So it's probably just the easiest to use. You just have a catalog. You pick what model you want, put a button, it downloads it, and then bam, we chat with it. It'll even tell you whether it's able to run on your computer or not based on your hardware configuration. So all the way to if you're running like a scientific pipeline that's like doing a lot of parallelization, a lot of heavy duty work, you probably want to use LLM on CUDA, like hardware on like a dedicated server hardware. And then there's like everything in between. But yeah, if you're just starting LM Studio or Ollama are definitely the place to start.
So which ones have you used?
I started out Ollama just for simple stuff, and then now I use the LLM like if I'm on hardware. Then if I want on like a data pipeline, so if like I'm ingesting a bunch of data, it can do a lot more parallelization and it's higher performance. But if you're just learning, you just want to do simple things or just have a little chat with your documents or whatever, like either Ollama or Ollama via LM Studio or perfectly fine. This was really new one. This one's it only runs on Apple, but it's accelerated by the MLX, the GPU, the specific silicon GPU. It's significantly faster than those. The other ones are adding MLX support, but whatever. And then if you want to do like super old school, it's Python, PyTorch. You have the Transformers module from Honey Base. But that's like if you're doing something really custom and advanced. So yeah, again, if you're gonna play with it, I would recommend LM Studio or Ollama.
These models, is it for what purposes are they? For what purposes? Is it work for your exploration?
Yeah, start out with me just to learn how it all works. Then I started with like for knowledge agents. So I have a collection of documents that I want to basically chop the documents or for the I use it for coding. So help me with writing code and stuff like that. But probably the most useful part of it is like the RAG and stuff I talked there where you have you're not gonna fine tune your own model from scratch. You can, but you give a system prompt and a collection of documents that you curated that knowledge you want to know, and then so you can on your local computer, even if they're sensitive documents, you can have a conversation with your local LLM.
Non-open access for the commercial ones, do they also allow you to do that locally, or you have to upload your documents?
Yeah, so you have to upload it because all the processing power happens somewhere in the cloud and the thing. So we do have we have AWS and which is Amazon. We have agreements with those, and we have with Microsoft. But if you're gonna upload any data, you definitely get like the use case reviewed and stuff to approve before you do. Just making sure the data, we're safe about data that's leaving the network. That's why, especially experimentation, I could do everything local because then I can't if the data stays on my laptop or on our own servers, it's a lot less risk. But if you're gonna do anything, uploading any data, especially sensitive data, any sensitive nature, you definitely want to talk to somebody and make sure you're not gonna get yourself in trouble. Hugging Face, I mentioned it a couple times already, but that's actually the logo of it. but it's going to be the way to think of it is the GitHub for AI. So everybody knows what GitHub is. It's code. It hosts code repositories and code. But this is the same thing, but for models. So it hosts models and data sets and spaces where people can play the models. So there's currently almost 2 million, there's almost 3 million models that are available on Hugging Face. And most of them are all derivative of foundation models that people have fine-tuned for specific purposes, like medical chat agents or whatever, whatever they want to fine tune it for, and then they've uploaded them there. But you can browse them and download them. Like in LM Studio, when you're seeing those models, that's where they're coming from. So you click on, they're actually downloading it from Hugging Face. But it's kind of like the analogy between like code repos, model repos. Discovering the stars and topics and downloads the tags. Readmes the small cards. It's like pretty much one-to-one analogous to GitHub, but for models instead of code. And then show all the stuff that is there. The product actually has an org that we established, but there's nothing in it. We just put it there as a placeholder, or when we get to this point where we start want to publish and share models to people outside the org. But so right now it's just a placeholder, but eventually who knows if we use it. When we start building models internally, when I'm going to share prompting, again, another basic thing. So it's just the analogy, like I talk the model, the prompt, but basic anatomy of the prompt is the system prompt, which basically sets the persona, the rules, how you want it to act or respond. The user is basically then that's just your question, and then the assistant is the response. You can see those three right there. And you can actually, when you send it, you can actually send it a couple pairs of just the user and assistant response back and forth. The initial response, basically it's called in context learning. It helps it see how you want the question is responded to, and then when you ask your open-ended question, it'll kind of respond in kind with what the examples that you showed it before. So that's called in context learning. That's in the prompts. And then prompt engineering, zero shot. Of course, you just ask it a cold call, like, hey, do the thing, or what's why it's color blue? There's a zero shot. Few shots that I talked about, where you're showing it if you're asking a question and providing a few examples of questions and responses, so it can learn how you want it to respond before it responds. Chain of thought, where you're going to ask it to break down step by step its reasoning, so you can see how it came to the conclusion. You can structure the output. You can try to constrain its output in formats, such as JSON. There's role prompting and everything. It's like you are a senior biostatistician. To kind of like put it in play a role. And then iterative refinement, that's just the technique where you just keep working, it'll respond and you follow up and keep refining on it until you eventually get what you want. And then some effective prompts, and not some effective prompts are like, help me write a grant. That's not very helpful. So it's like, you are a seasoned NIH R1 view reviewer. Critique the specific aims below for clarity, significance, and feasibility. Suggest concrete improvements, and then bam, you paste your proposal there. And then, that's a lot more useful than some of these over there. So again, don't say, hey, here's a CSV, analyze my data. That's not going to work. It's going to have to write code. So you're going to have to tell it, hey, here's the data, write a Python script that does these things for me. And then it'll work that way. And it'll just spit out the script. But if you're using an agentic system, it'll actually create the script, execute it, and show you the output. But that's another topic for on the agentic loop. The fine tuning is the way you can also affect the performance, I think the behavior of a model besides the prompting. So you do full fine tune where you have a training data set and you run through there and it tweaks every single weight in the model. That's very intensive and probably not what you need. And then there's other methods, LoRa, which is a parameter efficient tuning method called low rank adaptation, where the weight stays frozen of the base model and you're just training an adapter that you're going to fuse. It's going to sit on top of it. And then I kind of think of it as that adapter is kind of like a contact lens or a lens that sits on top of it that kind of warps it a little bit to tweak the model weights underneath without actually touching them. And then QLoRa is the same thing, but for quantized. And then I don't know, it's pretty hard to see, but that's what a training data set looks like. They come in different formats for different models, but they're basically just question response, bunch of series. You ask it a question and you provide a response. And you probably want thousands of these. You want a good training model. So these are, this one is examples of training a medical model on like some cancer stuff and some cancer medical stuff. You can get these data sets to do this medical training. You can either create your own, or there's thousands available for download on Hugging Face that people have curated and put up there to help you train models.
Question. Yes. Do you have any use case for when people generally do this fine tuning? Theory to the large models have been seen everything, right?
Yeah. So you probably want to fine tune if it's it's information that's like not proprietary. It's like some information that the models haven't seen. So like it's like in the dark, or for a very specific case or whatever. And generally, you wouldn't want to do this anyway. This is the last resort. The first resort is always, prompting, RAG, which we're going to talk about, running more context via RAG for retrieval augmented generation. We'll talk about a little bit, or in context learning. This is the last resort, and you can have some downsides as well, because when you're tuning these ones, it can make the model perform less well in other areas. So usually when I talk to people, they go, "Yeah, I need to fine tune this thing." I was like, "Oh, hold on. Do you really need to fine tune it, or let's see what you're trying to do?" And
That's like if you were going to do it over and over and over, and then it might be worth having.
Yeah, exactly. And you wouldn't want to cook in any information in a model that knowledge that's time, that changes over time. So it basically sets the persona and grounding of information, not specific. So for information about your org chart or something like that, you probably want to use that in RAG or something else. You wouldn't want to cook it as your model.
Gotcha. So nowadays, how people do fine tuning on the mobile computer exactly? Sometimes I know the Llama model to your computer. Do you have a specific package to do the fine tuning?
Yeah,
Write a code?
yeah, you can do it. You can do it old school like Python and PyTorch or whatever, but with the data set. But then there's models. There's frameworks to make it easier. The one I like is called the Onslaught, and yeah, you can go to Onslaught, search it up and you can find it online. But it's a framework you download that makes the process really easy. So if your training data set, you even use one of their base models that they've already, so it could be Gemma or Mama or one of the models, and then provide the data set, and it it just makes the whole thing super easy. You give it the hyperparameters that to do and having ethics and stuff like that. But yeah, it's called Onslaught. Onslaught or usually Onslaught, but it makes it much easier. So it used to be hard, now anybody can do it. The hard part of all these things are you have to have the good training data set. So that's the hardest part, is making sure you have a good curated, clean data set. That's the hard part of all this stuff. The technical part of doing it, that's not hard anymore. It's the data that's important. And then eliminate hallucinations and grounding. So again, everybody you've heard of hallucinations, but if the model doesn't know the information, it can make it up. So in that latent space, that embeddings we're talking about, the way I try to think of it is if there's whatever you ask your question, it ends up in some sparse space if there's not a stuff or a lot around it. It'll grab a lot of things and fabricate, make things up, so it doesn't have a lot of knowledge in that area. And the way I think about it is, it's not really lying per se. What it's kind of like taking a test. If you're taking a test, if you don't know the answer, it's better to just guess than to leave it at not answer it. If you don't answer it, it's 100% wrong. But if you guess, you might get it right. So that's kind of the way that they act. So there's some you can tell they'll just completely make some low stuff up if you ask it something that has no idea about. So you can there's grounding strategies, the RAG, which we talk about, active and types sources that you can verify, constraints, output, or in an agentic system, you can have do two calls to look up to verify it. Again, we're going to talk about the agentic stuff quickly. And then ungrounded generation, you're doing anything high stakes, writing paper, doing your name on reputation and stuff like that. This is very dangerous. So you definitely want to validate all your sources. And speaking of that, so I got to do statistics for this talk. Back in 2003, 2023, but 1 in 3,000 papers had hallucinated references. But now it's 1 in 277. So dramatic units of same references and citations in scientific papers. And again, and then there's my sources there, so I didn't make it up.
Wasn't resources sources made up.
Yeah. I thought about those. I was going to talk about making sure you cite your resources. What should I add them on these? Yeah. But yeah, never trust that AI is generating citations for you in a paper they're going to publish. I mean, it could be very bad. And then RAG, this is the one way to ground it, so it's way less. Is the way it works is you have your own private data, and then it's going to look in that data for answers. So you ask your question, it's going to embed your query, use a cosine similarity against the vector database to pull up chunks of that, insert into the context with the prompt when the LLM sees it. So the LLM has your prompt and the most likely chunks of documents that would answer your question, and so that they can answer that. That improves it dramatically. It's still not perfect, but it does a lot better. And I'm going to show you, and there's a little diagram after this. But anyway, you need an embedding model, which we talked about, a vector database. There's a thing to store those vectors. specialized to do that, similarity matching and semantic stuff, and chunking strategy. What size of chunks, how much overlap, those are the parameters you tune there. And then, lab notebook, Q&A, literature sentences, protocol search, a grand knowledge base, whatever you wanted to do, you wanted to supplement the model, the private data, you do right. And then just a quick diagram together of it. So all the blue stuff is ingesting, like querying knowledge. So you get your documents, you chunk and overlap, then you send them through the embedding model, generate the embeddings, store the embeddings in the vector database. And then when you ask a question, it also embeds your question, your prompt, does a cosine similarity search within the vector database to pull out the chunks that are similar, that are close to that, and then injects your prompt with the chunks that have the top match into the initial thing the first time it talks to the LLM. So the LLM see your prompt, and then some document chunks that most likely have a response. The answer it needs to answer your question. So this actually works really well. Again, you have to tweak, chunking strategy, so sometimes you might chunk the whole document because you don't want to break things up, but this dramatically, this is how you get to know private data. So we wanted to make center net has terrible search, but we want to, I mean, I've already done it before, but anyway, for all these center net, put it into a database, I chunk it, I put it in there, and I can ask it anything, anything that's ever been on the center net, you can answer that question, correctly. And it can give a resource, it cites where the document chunk or the document where it came from too. So it gives you citations where it found.
This is also the way to sort of create your own ecosystem for everything that you have.
Yeah, exactly. Yeah. So this would be these to be your private documents you don't want anyone see. Your private research.
And you run it on your models on your own computer.
Yeah.
So everything is just
exactly. So this all stays local. Everything stays local. So this is how you make it know your data.
So the difference here is there are two steps, as you said. There's one is that the question to query, and then the other one is the documents. But sort of you do that once, and then every time you just doing the inference on the query.
Yeah. So just in Python, you have this automated, it's picking up documents from a folder, but that it only needs to do that once unless you need to update it, something's changed. But then after that's done, you don't have to do that again. You just talk to her like normal, and it'll pull chunks from the database to answer your questions. It works great. It works really great.
And do you want to say how you set that? Or
How?
I mean,
Oh yeah, right. So there's I have code issue, but I mean, so yeah, you just write a chunk, or there's you can just write your own, or there's things like llama index, or what's it I don't have my own stuff, but there's frameworks that help you orchestrate the whole thing. It's not difficult.
I have one question. Why is there an arrow from prompt, the orange one, to the from plus top end transcode line? Why is there that error? I thought you should go down the embedding model and then up, but there's a direct error there.
Yeah, I mean, I guess I just put it together this morning, so I'm not sure, but so yeah, it could. So you still want the original prompts to be sent to the LLM, then you also want the chunks.
Ugh.
You want the chunks that match it down there to be appended to it. So maybe you just didn't draw it right, but the LLM is going to see your original prompt, and then the chunks that match appended to it when it receives it. And then so this is great for this type of knowledge. But then you can also augment this with tools like tool calls. Like you can actually have it used. It's even more accurate. Then it's actually use direct database queries and look up some tables and stuff. Well, I think that's the next talk here. But so there's what does Agentic mean? Everyone uses that term all the time. So you have chatbots, which is just a single back and forth Q&A. You have a co-pilot that can run tasks. But an agent is something that plans and acts autonomously. So it decides what it's going to do to your question. So it does. You ask it a question, it'll do planning. You might call some tools, which I'll show you what that looks like now. We still call APIs, do database queries. It has memory of previous interactions with it. It will reflect, and it's a loop. Because I have a video in the diagram that they understand. But the function calling, so you never want to have RAG, retrieval augmentation for something like the temperature or something in a live production database that's changing on the fly, or something you need to be very precise. What you can do is create a tool, and a tool is it's basically part of the prompt. You give the prompt, but then you also give it a list of all the tools that it has available. The agent can call. And for this case, in this example, it has a weather tool. So you ask it, hey, what's the weather in Seattle? The LLM will think about it and go, I don't really know, but look, I have a tool called Get Weather, and it'll look at it and go, yeah, I want to call that one with the parameter of Seattle. So it doesn't directly call the tool. It responds with the JSON output that the agent sees. Oh, and if it wants to call a tool, your code or the agent calls the tool for it and provides the output of the tool call to the LLM in its response. And then it sees your question and the response, and then it can go, oh, it's something Seattle right now.
Is
Yes.
that similar to skills then? Our tool is this the same?
No, it's like I have to find out that as well. So yeah, this is how. So I do a lot of this now too, where I have to look up. So I can ask my models like the agents. I can like what time it is. It looks up in the database, or if you're asking it, what's the status of this XYZ right now. RAG's never going to tell you that. It's going to have to use a tool. And you can write the tools, but their API. There's another thing we call MCP, which makes that a lot simpler. So like before MCP, like so the tool calls, and I still do this now because it's just it's less overhead, but for me, but anyway, before that, you have to write a tool, like an API tool for every single thing you want to do to set it. MCP is this new standard came out with Anthropic, where it's kind of like a standardized interface to call tools. You call MCP, which stands for Model Context Provider. And the kind of the slang for it, it's like the USB for tools. It's like you just plug, you have so all these different companies, there's hundreds of thousands of MCPs out there for every app you can imagine. You just find them and you just plug them into your system, and it'll discover them and just know how to use them without a lot of overhead. The MCPs can provide tools for all things, like, resources, like data, or prompts. Say you can bundle those three different resources in an MCP. So that's how you would talk to like Google Sheets or Notion, or where you want to look up something if you're seeking note taking app or whatever. There's an MCP for that, so your agent can reach in and talk. And then here's the difference between the skills and MCP. Those skills, in some cases, it could replace an MCP, or it could be complementary. So like but still, basically, that's like it's a how-to on how, if you're telling them how to do something. And if you can accomplish it with a CLI, like a command line interface, you can tell it, instead of calling an MCP or an API, you can actually just execute command line utilities on your computer, which is better than MCP in some ways because it has way less overhead. The MCP servers inject a lot of context into the discussion, which, needs tokens, it slows things down, costs memory. So, but then they can also be paired together. So it can be complementary. So a skill teaches it how to write the SQL code, and an MCP actually queries the database. So you can use them together, or in some cases, people are completely replacing MCPs with skills, or you can use them together in this case. But again, a lot of stuff you can look online, this whole guide on how to create skills, and a lot of agents now, like, if you have, Claude or whatever, it already knows what skills are. You tell it, make me a skill of XYZ. And so it basically, Claude already has a skill on how it makes skills. So you can ask it, hey, I need a skill to do this thing that and here's how it does it. Here's the documentation. It'll build a skill, save it. So the next time it needs to do it, it'll know how to do that thing. So it's high capability. So again, skills are newer than MCP, and they're going like the skills are everything. And then the model on its own doesn't really do anything. You need like a harness. So they're calling it harness engineering and stuff down. So, but the harness is the thing that orchestrates all this stuff. It's taking the input, feeding to your LLM, executing tool calls, looking up things in knowledge base. It's basically good. And you can keep looping many times, multiple tool calls, lookups, reading, to have the final result. So the harness, so Claude Code, that's the harness. So Claude Sonnet 4.6 might be the model, but the harness is Claude Code, the thing that's orchestrating the inputs and outputs and calls. So the harness is really important. So like if you're OpenClaw, I'm sure, the OpenClaw is a harness, Claude Code is a harness. A lot of these systems are harness. It's like, Cursor, they're harness. But they handle the tool call routing, they handle the retries. They have safety guard. They decide, okay, what's good enough, when to stop. But they're like the orchestrator of all these things. And then AI assisted software development. So that's how progressed, where originally it was just tab completion, where it kind of would guess the next word, you keep tab, and it would help you write your code a little faster, but you're still writing it. Then you have chat coding, where people fire up ChatGPT and say, hey, I need a Python script that does X, Y, Z, or hey, I'm getting this error message in my code. What's wrong? And then it paste things back and forth between the chat window. And then that then became agentic coding where it's like in running your IDE, it's editing the file locally and running tests. And then now we're at the stage of vibe coding where a lot of that's been abstracted away. You can just go, make me a cool app and just sit back and let the app be big. So that's vibe coding. It's kind of like the trend. But with vibe coding, it can be fun, but you don't really know how it's going to do, how it's going to get there, what technology it's going to use. If you want to keep it on Rails, so you get something that meets your requirements, you have to put something now called the spec-driven development. So you're going to basically, Eric Bassett talked about this briefly. I have laptop. He used Spec Kit from GitHub. So that's one of them. There's many of the different models out there, but you're going to save time instead of writing code now. Software developer spends the time, the requirements and design and all the upfront work, and then the agent takes that and builds up a plan, and until completion. So you write spec, you implement it, you review it, ship it, but this one's a little better. Good. So I wanted a demo of an actual scientific kind of thing instead of a normal IT stuff I did. So I wrote this app called Proteoscope, which can do 3D GPU accelerated visualizations of protein structures. So to create that, instead of just asking for that, I said, talk to it, say, hey, what I'm trying to do, and it'll build out like a requirements document. So it explains what it is, requirement 1, user story, acceptance criteria, this can be a full document. So it helps the AI, helps you build that up. Then you go, okay, now how do I design this? It'll build the design. And you can influence that, like, what programming languages, or hey, you're using AWS versus Azure, or you have to explain some of the stuff. And it'll build the design. So that does like the job of the software architect. It creates, that you can see the whole document. It's like 10 diagrams of the thing explaining how it all works. Then there's kind of like project management kind of aspect of it where it looks at the requirements in the design. It breaks those up into a bunch of tasks, and it tracks them too. So it'll say task 1, set up, and then it matches the requirements. So it'll say requirement 1.1, 1.2. So it shows what tasks satisfy which requirements. And then it has the supervisor, which is coordinating all this stuff. So when it'll dispatch it to the developer that, okay, I'm done with it. It'll have a QA agent run tests on it. If it passes, it'll mark it off as completed in the checkers. If it's not, it'll kick it back and say, no, do it again. And he'll keep doing this loop until the application is done. And then, you have this, a little bit in real life, this web, but it's there's a link to it if you want to download it. But it's a desktop app, but it's they use some technology called WebGPU, which is kind of new. It's surpassed WebGL. So it runs really smooth. You can have like, million particle, atom simulation, and it's like 3D. You can dive into it, spin it around. It's pretty, I don't know if it's a good app or not, but it's cool. So I just wanted to tell you about some kind of a research type demo to talk to. But yeah, based on these documents that I helped create, he created this whole thing, and it just works the first time out of the box. If you vibe code, it might not give exactly what you want, and you have to do tons of iterations. So this upfront work you do here with all this stack-driven development, it pays off. Yes.
Did you say, so back to your document page where you have the 3 tasks? Yeah. So which one, did you say you wrote all 3 of those, or you wrote the first 2 and then?
The AI writes them, but with your help. So I say, hey, I want to do spec-driven development. I want a requirements, design, and task document. And then you explain what you're trying to do. And it'll act as like a business analyst, and depending on the agent, he can ask you questions. And you iterate back and forth with it, and it gets until it has enough information, then it'll create all these things. So it's kind of neat. It replaces like a whole software development team.
In the back end, what I was going to add, one thing that's been working well for my team is before you dive into the specs, you tell the agent, look, I have this idea, interview me to know more about the project. Then it's going to keep asking you questions, right? And then it goes and write down the stats.
And so this is on your own agent, Boho agent, done on your Boho agent.
But it doesn't have to be.
So it could be done on Cloud Code or something.
Yeah, you Cloud Code for this.
I always ask Cloud Code, do you have any questions? And always ask questions. And they're all spot on.
So there is a very nice tool that is called Grill Me.
Really?
Yeah, if you inject that, it's exactly to do this type of interview to know more of the project you want to develop.
But it's a lot faster than talk to the PMO and get the DA to come out and talk to you. And before you can schedule a meeting, you can already have a working application. So don't tell them. they don't want to lose their jobs. Or just kind of means,
They just do more.
yeah, you're true.
Maybe just do more. We will all have superpowers. That's anyways.
I think if you do it back, I think the place where it's powerful is we might not know how to evaluate it.
Yes.
And so that's where that expertise comes in, right? If I did this, there's 100% that I'm going to go to my friend who used to be a senior software engineer in Google and say, hey, what does this look like? Am I going to go spoof something up? And that's how then I get to learn. And, you get to be careful. So I would say it's not so much, it's just like, when do we do the touch points,
So you go to your Google first.
I would, but I've set them up. People that
I would say it does make it a lot easier being like a software engineer or
yeah, I mean, you to yourself,
like
but
if I can look at it and go, no, I don't want to do it that way. I want to do, I can tweak it. So it does help a lot to have that experience.
The whole point is to get things fast.
Yeah.
You're gonna wait and go to talk to your friend.
no, but then you learn, right? So if I do it the first time, knowing where it is that I need to know something else. Like I'm not thinking about, I'm not thinking about, I just forgot your name, so I'm looking at Robert, being able to do it because he has his own brain. I have my brain. My brain will be really good at the tasks I want to do, but not on assessing whether the setup or the architecting of the task is in any way robust. So I agree, but I think after a few checks, I mean, I had you were my image analysis person. And now, there was a point where I didn't do that anymore, right? And that was PAI. It was just all NI.
But normally it's right. Normally I'll contradict you too much, especially if you get the right information. Ever since around like the beginning of the year, whatever, you're at a new level. Like so the whole Opus 4.7 or Claude. I'm going to bring on a lot of OpenAI 5.5, but the X high, the extra high, the building for everyone. The output, the engineering does is like excellent. It's like so there's before when a long while GPT-4, I thought I would disagree a lot. No, it's crap or whatever. But now it's kind of like they're really dialed this stuff in. It's like getting amazing now. But yeah, stuff if you download that thing, I don't know if it's good. if you do proxy.
You want somebody to take a look at it, don't you?
I already sent to a couple people to look at it. It was fun. But I mean, to me, it looks cool, but I don't know if it's actually responsible AI research. So, where it helps, with writing, through readability, grammar, graphs, brainstorming, summarizing, critiquing, aims, so that it shouldn't replace your conclusions or interpretations of things. It, don't replace critical thinking, so you guys have heard this before. So that would be important to add this there, but just definitely use it, but then be aware of these things. It shouldn't replace your judgment. Again, because at the end, especially if you're writing papers and publishing, it's you're on the line, so you definitely have to take care. They'll replace critical thinking, and then again, I got more citations for these. These probably change all the time, but this is what it was like a week ago, and I started gathering state information. But the different policies for submitting, AI use in journals. So some of them say you're allowed to use it for readability. Some say, hey, not even at all. It's scientific misconduct if you even use it. And some are like, in between. They vary. So you check, because I imagine these policies change all the time. Those are the sources I got this information from. But yeah, some of them are really strict and like no generated text at all.
Where is that?
That was the science. I don't know if this.
Yes.
Anyways.
No generated text.
And it said, I found this was interesting. Contradictory though too when I was reading the thing, but I read the thing over there. It bans all AI generated text entirely, but there's a point to do full prompt disclosure on your required. No, I didn't get that part of it. So no, I didn't really understand that part of it, but it's contradictory.
So something like asking for feedback on drafts or giving you points for you to improve your writing or brainstorming with.
Yeah, I think that's one. Yeah.
That doesn't fall kind of into where these
No.
are. That's more just to the text that's actually submitted.
Yeah, exactly. Yeah, I think if on the line is you can just have it write it for you and paste your information, then that's what you get in trouble.
But what happens if you ask it to edit?
Yes. No.
Okay. You still have to be really careful. I
I
don't
think
know.
we need to get some.
You guys know more about this space than I.
There's like 5 titles out there to check. That it's the
Oh, yeah. Tonight.
Well, they all have accents. Each of the models. Yeah, they have.
I think for some of the journals, they also provide a link for you, like the AI editors for you to check before your submission, and you pay for that. I think it's about 60. $60. So some journals provide that service to you to use it, and you should clarify that I used it for editing around my last like my final post submission.
And then
Yeah.
and then for like reproducibility in your own documentation, like so if you use AI or even in your research, not just for paper writing, in the document, what model you use, what version, keep your prompts, keep the raw outputs, keep all that stuff. Uh, so you document, exactly how you got that data, how it was created. You know, because of all of this part, like creating bias, the models have knowledge cutoff. That's where the RAG and tool calls come in. They don't really understand biology. And confidentially risk, so consumer services, you don't have a VA with, you're sending PHI, there's a risk there. And other ethical considerations. But again, yeah, just a real quick thing put together, like, once you use it and when not to, prose, grammar, brainstorming, yeah, sure, go ahead and use it. Not really worried about that. Writing code, summarizing things, and doing tests. Use it, but then make sure you validate to make sure that it's generating what you want. And then the risky part is like when it's generating citations and drawing scientific conclusions and things like that. That's where for the science folks, that's where the extreme risk comes from. And again, it isn't can AI use this, but can I verify the responsibility for the result and report your test result? And then Hutch have a little some guidance on it as well there on side of the I think that's it. Well, I went way over.